So, hi everybody, and thanks for coming to my talk on 7702 called Migrating the Coldest EOAs. So I'm Nicolas Bacca, co-founder of Ledger, one of the 8, and now creating something new called ZKNox. We are optimizing cryptographic libraries and tools for the Ethereum ecosystem. So, well, first to be very, very honest, I lied because I thought that the state of the industry would be very different when I created my slides. So I was just a little bit optimistic. The good news is that we have some implementation of 7702 for hardware wallets. Ledger is the first one, so it's just a coincidence. So Ledger are ready, but it's not integrated in wallets yet. On Keystone, I have a PR which has been accepted, and on Trezor, I have a PR which is still pending. So I will change a little bit the topic of the talk, and we'll speak about 7702 security a little bit more generally, and design choice for hardware wallets. So if you think that that matches your expectation, you can stay. Otherwise, I won't take it badly if you leave. So first, maybe what is 7702? I will do a very, very short summary because there has been already a talk in Monroe a little bit before. So if you want, you can look at the circuit talk. The main idea is that you have an EOA, you can turn your EOA into a smart wallet. So basically, you will point to the code of an already deployed smart wallet, and your EOA will gain the capacity to execute this code. The thing to remember is that the EOA can still originate TX. So it behaves both as a smart contract and as an EOA, which means that if you want to migrate, for example, you can still use it as an EOA, so you can migrate gradually. The delegation is permanent, but it can be changed and it can be revoked. And today, 7702 is live on mainnet with the Pectra update, so as the 7th of May. How does it work? In details. There is a new transaction type which is created called type 4 with an authorization list here. And the authorization list has the address of the delegate, announced a signature. Here you will think, okay, so where do I find the address of my EOA? If you want to find the address of the EOA that created the authorization, you have to do an EC recover with the signature. The signature here, the algorithm of the signature is given there. You will see that we are doing a check of something that is very, very specific. So we are adding a magic prefix, and then we are adding part of the data and code it as RLP, which means that it cannot be signed by a regular wallet. We'll see why it's important in the next slides. Common things when you do that, so when you use 7702, you will always note that there are very fine prints in the specification which are good to remember. So here the authorization list is processed before the execution portion of the transaction begins, but after the standard nonce is incremented. That was a bit long to read. But this basically means that if you are self-delegating, you should set the nonce to nonce +1, which is not obvious when you look at it. And something else, you can run into some issues with the storage when you are delegating. Why? First, because you can run into conflicts. Let's say you delegate to one contract, you delegate to another contract, you use the same storage slot. They are not initialized, you can run into bugs, or worse, you can run into security issues. 7201 can help with that, but the contract, of course, has to use this storage hints. And you can run into, that's a new problem, a potential waste of space. So if you delegate to several contracts, of course, the storage of your EOA is still being used, so you will end up with waste in your storage because we don't have destructors. So maybe it's the opportunity to run defrag for smart contracts, but yeah, at the moment, it doesn't exist. So there is not really a solution for that. I would say it's up to the contract to clean up if you want to change the authorization. If we want to look quickly at the state of 7702 support today, we have 9 chains supporting it, actually 10 chains because I forgot about Circuit. I looked at their talk. So they have 7702 and nice cats on their chain, so it's cool. We have 5 wallets supporting it. So Embayer, MetaMask, OKX, Trust, Uniswap. Few hardware wallets, as I mentioned, a lot of embedded wallets, so they are not in this document, and about 24 dApps. So we have more and more dApps supporting. We have a few major dApps. We don't have the biggest one, I would say. We don't have Aave. I don't think we have Curve. So well, there is progress here, and we will have to define what support means, because support is kind of a confusing term. Here it just means that the dApp is ready to support new wallet extensions defined in EIP 5792 that we will speak about in a few minutes. Now let's look at the use cases. It's where things look interesting because it's absolutely not what you would imagine. You'll see that most delegations are issued by Uniswap. So that looks confusing because Uniswap is a dApp. So I think actually those delegations are coming from Uniswap mobile wallet. So when you are both an embedded wallet and a dApp, 7702 can let you make good things. And MetaMask comes a close second, but you see very low. As we would expect, the most delegations are on the chain where it's the cheapest to issue transactions. So that's not really a surprise. But the surprise maybe comes here. You will see that looking at the different value in the dashboard, the best use case for 7702 today is crime. So, well, it's a common meme, but we'll see. I don't think it's true. So we are not actually doing crime. So why do we come to this very, very surprising result? Because we have a lot of private keys compromised over time. And if we look just as a very simple PRNG compromise, so if your PRNG is 32 bytes of entropy, you get automatically 4 billion vulnerable keys. So that was the case with the Trust Wallet problem on desktop. So it's super convenient to use 7702 to auto-sweep the ETH if you are a bad guy, because before 7702, you had to watch the chain for any incoming transaction, and then you had to fight between bots. After 7702, you can just delegate in your contract to a sweeper. So you can say, okay, if I receive some ETH, I will just send it somewhere else, and you don't have anything else to do, and then you can automatically steal, you don't have to fight anymore. So that's why I think it's very opportunist. A lot of people are just delegating to known compromised addresses because it doesn't cost much, and the reward can be large. So to fight against this, Wintermute and Etherscan added automatically this small text in the contracts that are affected. So you know that if at some point you are delegated or you see this contract, well, it's bad news. Myself, I did a small CTF experiment. So just after the launch of Pectra, I put 7.702 USDC that were easy to sweep if you reverse the contract. So you still have to reverse the contract. The good news is that it took 1 month to be caught. And actually, I think it was caught by an attacker that hacked another protocol. So I don't think it was done automatically. It was very easy to hack once you see the code. You see, oops, sorry. Because it was basically, you could just call the transfer function with the address of the USDC and you would get it. I didn't put $7,702,000 because, well, I'm a bit cheap, but it was enough. And someone managed to hack it after 1 month. So you have the transaction here. You can maybe see who is the attacker if you're interested. The other side of this, which is good news, is that it can be used for assets recovery. Because if you can do this delegate thing, it means you can send transaction without sending ETH to the affected contract. So you don't need to fight against bots to recover assets. And here we have already an implementation that has been done by SEAL 911 leader Pectra. And we have on GitHub something you can use if you want to recover if you want to do a recovery of something that is a bit complex, like ERC20 tokens or staked assets. You have a framework that is going to help you. Of course, we can still revert. I mean, it can help you, and for attackers who want to fight you, they can still try to redelegate the contract to something else, but for the good guys, it's easier. And just, yeah, because I like when things happen right before a presentation, I have seen actually an authorization race happening on a real blockchain, so on mainnet. You can see here bots fighting for different delegations, so trying first in one block, then the second one, then 2 blocks after, and well, they tried this for a bit. I think after they got tired of it, but basically you had people trying to put their delegation on the same address because the private key was compromised, and well, at some point someone might be winning if this address is receiving more ETH, or it can just be wasted ETH, hopefully. A few questions you can ask about 7702 from a security point of view. So are you at risk of signing a malicious authorization? The good news, if you've seen the signature, it's a very specific signature, so it can't be signed by a wallet unless the wallet supports 7702, or some specific cases that I will speak about. So if your wallet supports ETH sign without adding a message prefix, then, well, it could be compromised because, well, you could be signing an authorization you don't want to sign. And something else, because we have clear signing, we have blind signing, I suggested to coin vibe signing. Vibe signing being, well, okay, I'm just signing a hash. I don't even know what I'm signing. I have absolutely no context of this. Then in that case, of course, you could end up signing an authorization and you could end up, well, delegating your account to something that can drain you. So hopefully we don't have many wallets supporting this. I would say those are mostly NFC cards. But I don't want to name any vendor because I think my screen is too small, so that's good. But let's say that if you are a hardware wallet vendor and you think that putting large pictures in Paris suburbs rather than passing transaction on your card is a good idea, it's not. Just well, with 7702, it's a demonstration of that. Next question we can ask, are we solving magically everything with 7702? Of course not. It's a way, it's a path. Before we have native account abstraction, so before we could skip redelegating contracts, so with 7701. The main use case today of 7702 is to move towards account abstraction for EOAs, so preserve the history of your account, because you can have a lot of stuff you care about. You can care about your transaction history, you can care about your soulbound NFTs, whatever. We can have some more exotic use cases where people will be using 7702 to deploy contracts without knowing the private key. So you can actually make a cryptographic proof that you don't own the private key that was used to create the contract. So something called PrEP. If you're interested, you can look into it. But since the EOA still exists, another thing is that there are a few use cases that are very interesting that we can do. For example, we can create a 101 safe, which is quite a common security practice for key rotation, because if you do this, since the EOA can still originate transactions, it's completely useless, because if your private key is compromised, bad people can still use it to originate transactions, and DApp support is really essential. So now we will look at what hardware wallets actually can do, what are the choices they can do, and what DApp support exactly means. Regarding hardware wallets and smart accounts, they make things very, very complicated. There is one thing I like to say about hardware wallets is that we can apply the notion of plastic roaming that we have with SIM cards. You could switch signers very easily before. So you could just say, okay, I'm taking a wallet front end, I'm taking my hardware wallet, and everything is going to behave the same way because the specifications are the same, because one transaction is one transaction. With account abstraction, with smart accounts, it's pretty different. Two accounts can define transactions in a very different way, and in the end, the signer would need to understand how to sign them in order to be able to switch from one wallet to another. So actually, account abstraction can be a burden for hardware wallet and for all kind of external smart signers. So the providers decided to make a shopping list. We have several items there. The first one is that we can't delegate to anything, which seems quite reasonable. So we have a strong control of the delegate. We only want a basic set of features. So we only want batching, we only want sponsoring. We'll see what this is. We would like the smart account to avoid breaking clear signing as much as possible. Sometimes it's already difficult to verify all kind of call data on the hardware wallet. So we don't want to make it worse, actually. And another strong item in the shopping list was to reuse existing delegates, so not create specific contracts for the hardware wallet. So let's see what we can do with that. Batching is super simple. Batching just means that you are going to send several transactions in one transaction. Typically, you would use that to not do the approve and swap dance. You would put the approve and the swap in the same transaction. And it's very important, in my opinion, to design your contract to work with that, because another option could be to do the batching in an external contract. This is what Safe did, for example. The problem with this is that you have to call this contract with a delegate call, because you need to operate with the same storage as the calling contract. So it can lead to a lot of problems, as we have seen with Bybit, but a large reason of why the Bybit hack was successful, in my opinion, is because it was easy to do delegate calls with a Safe. So better design it in the contract directly. There is one protocol to do that, one specification called 7821, which specifies a very simple batching mechanism with ABI.encode, which is also self-sufficient, so dApps can call the interface and can see if the contract is going to support this method of batching. So it doesn't support signing. So it just designs how to do the batching. So hardware wallet could use that. I mean, if you have a contract compliant with it, then the call data is easy to pass. Then with 4337, so with 4337, it doesn't specify batching directly. So important thing to remember, 4337 only specify what makes a user code valid. So then batching can be done with a lot of different mechanisms. And for example, we have one contract supporting ABI encode, which is the basic contract of 4337, which is called simple base account. And base account also supports signing with 4337 with the entry point V8. It supports signing with EIP 712, which is already passed by hardware wallets. So we have a nice way of looking at all the user app. If this seems a little bit obscure to you because you're not familiar with 4337, I will redirect you to the circuit call, circuit talk, which went into this with a little bit more details because I am quite short on time, unfortunately. Then sponsoring, what is sponsoring? You want the user to avoid paying for gas, or at least avoid paying for gas in native tokens. This exists for a while. I mean, before 4337, we have meta transactions. Then what 4337 did is that it standardized sponsoring in a decentralized way. So that is what was introduced with the paymaster logic. So here, the idea of the paymaster is that you will validate the transaction, and then the paymaster can sponsor, can pay gas for the transaction for you. Again, I'm going quickly on that because, unfortunately, I don't have a lot of time to talk about account abstraction. And regarding dApp support, so if a dApp wants to support batching and sponsoring, the options they have is either to take a shortcut with 7821 or to support the full EIP 5792 with wallets and calls. With wallets and calls, you can do batching. You can also do sponsoring. So which is sponsoring in both ways. So the wallet can specify a paymaster or the dApp can specify a paymaster. One thing that I thought interesting, so I didn't verify it myself because the DGen one is not yet available, but I saw it in a conference. They are using 4337 in the back, but they are hiding it to the front, which means that for the dApp, the wallet looks like an EOA, so there is absolutely no integration to do. It works with all dApps. But in the end, this embedded wallet will sponsor transaction through a paymaster. So you end up with something that looks like an EOA, but can pay gas for the user. So I think it's an interesting use case. I don't know how scalable it is because you would have to sponsor a lot of transactions. But if you want dApp support, it's a nice way to do it, in my opinion. A very quick review of popular delegate contracts that were chosen to be integrated into hardware wallets. And in the end, that choice was made by which standard part can we reuse. So we ended up with MetaMask and the default account of ERC4337. Why? Because we had standard batching, that we could have a shortcut if we wanted, and we had clear signing. So clear signing is the most important thing for a hardware wallet. We thought that the first two were maybe a little bit more complex or didn't have clear signing. So my preferred choice today, if I have to reuse something, would be to reuse either the MetaMask delegator or the base account of 4337. If you want to test with Ledger devices, which are the first devices which you can test today. If you want to test a new delegate first, you can build the Ledger application, the Ethereum application, change a whitelist. So something that is quite easy to do. I mean, you have the GitHub reference of the application. But if you are using already one of the supported contracts, then it's easy. And to use it with your dApp, with your wallet, you need to integrate with a piece of software called the Ledger Device Management Kit. And again, here I pointed to the specification because you have already a list of what you can do to sign a delegation. Once you sign a delegation with your ledger, you would have to form the transaction, so the type 4 transaction in order to send it, but this is left to do for your wallet. Maybe I have 1 minute, so I will go extremely quickly on that. If we want to go beyond some ideas, and some ideas still security-oriented that I thought might be interesting, how could you recover your wallet if you lose your seed? You could imagine recovering it with a proof of your passport, with a proof of your Gmail account, and something else, you could add some extra security to your wallet, so have a Web3 firewall directly embedded into your wallet, and for example, reject the transaction if the transaction has been pointed to be something going directly through a phishing address or a domainer. How would you do that? The answer, you would do it with ZK. So I think it's kind of an answer to everything at the moment. Why is it good today? Why could you do it? Because you have good frameworks that let you compute ZK proof locally, which means that since you can compute them locally, they are always available, and you have good privacy. So if you want, for example, to verify your email address, you want to do this locally, you don't want to delegate it to something else. I pointed to a framework that lists different zero-knowledge proof frameworks that you can run directly on your computer, so-called MoPro. If you're interested, you can look at it. And well, it looks like an idea, but I think actually it would be good to implement. And if someone wants to play with that during the hackathon, during this global hackathon, why not? I think I still have 20 seconds, so I can just say thank you. This is my Twitter account. When it's not suspended, you can send me questions. And that's it. Thank you.